Right. Next set of notes. So we've already discussed the slope-intercept form. Remember, f of x is just the fancy label for y, so it's function notation, point-slope form. Again, f of x is the fancy label for y. You could see either of these with just a y instead of the f of x notation. There's a third form called standard form. We don't see this too often, but this is what it looks like. A lot of textbooks prefer the capital ABC, and conditions on those are no fractions, which means you'd have to clear all of them. And the first one, the coefficient of x, a, it has to be positive. So like I said, we don't see standard form too often, but you do want to make sure you know what it is in case you need it. So example 1 is a you try it just as a review, so I will leave that one blank, and you can check that one with the notes if needed, just to review what we just finished covering. So we'll go on to example 2. So it says using the slope and y-intercept of 1/3 x plus 1, determine whether the x-intercept is positive or negative. All right, so using the slope and y-intercept. So if I'm trying to figure out if my x-intercept is positive or negative, I would like to draw the graph. So my y-intercept, remember y equals mx plus b. So b is the y value of our y-intercept. So our y-intercept is going to be the coordinate x is always 0 and b is 1, so 0, 1. The slope m is what is attached to x, which is 1/3. All right, so we're going to use these two things to sketch a graph and then play connect the dots, and that will let us know if our x-intercept is going to be positive or negative. So over to my graph, my y-intercept 0, 1, so I'm going to go to that point and put a dot. My slope 1/3, remember it's rise over run. So we're going to rise 1 from that point. So from my point, I'm going to go up 1, and then I'm going to run 3. So remember, run is positive, so we're going to go to the right, 1, 2, 3, and this would be, that's a little low, this would be the location of my next point on my line here. 2 points is enough to play connect the dots with a linear function or linear line. So I'm going to play connect the dots, and we get this line here. So we're looking for not the value of the x-intercept, just is it positive or is it negative. So if we look at the x-intercept is where we cross the x-axis, which is going to be somewhere here, so right around there. It doesn't look like it's quite -3, but it is close to -3, which means the x-intercept is going to be negative or less than 0. So the x-intercept is negative. All right. So next example, sketch the graphs of x equals 3 and y equals -5. So these are special types of lines, and it's helpful to just know what each is. The equation of a line x equals a number. So notice both of these equations do not contain an x and a y. It is only an x or only a y. X equals a number means you have to cross the x-axis at that number. So this results in a vertical line. The equation of y equals a number means I have to cross the y-axis at that number, which results in a horizontal line. So x equals is a vertical line, y equals is a horizontal line. There's some special things about each of these lines. So let me get them drawn in first. So the x equals 3, I will draw first. So here is 3 on my x-axis. I have to cross it, get my arrows. The line y equals, we will do in green or seafoam, whatever color that is. So -5 is here. Get my arrows. So there's our two lines, and I'll label them off to the side. Oops, purple. Alright, so there's our two special types of lines. So another thing about these two lines is their slopes are also special formulas. So if you think about rise to run, a vertical line has an undefined slope. So if you were asked what is the slope of a vertical line, it is undefined because the denominator is 0 when you try to use the slope formula because the x values are all the same. Y equals a number, a horizontal line, has a slope of 0 because the y values are the same and the y values are in the numerator. So x equals undefined slope, y equals slope of 0. And then there's your little reminder down there. All right, next thing we're going to get into is parallel and perpendicular lines. So important things to know is that parallel lines never intersect, which means the rise to run ratio has to be the exact same. So parallel lines have the same slope, but technically a different y-intercept. Otherwise, they would be the same line. For perpendicular lines, there's two ways to look at it. You can use the rule of opposite reciprocals or the fact that their slopes product or they multiply to -1. I like the idea of opposite reciprocals, but again, they mean the exact same thing. So opposite means change the sign. If one's positive, the other has to be negative. Reciprocal means the numbers are a mirror image of each other. So you just take the value of the slope and you interchange the numerator and denominator. All right, example 4. Determine whether the lines are parallel, perpendicular, or neither, and give a reason. So parallel, perpendicular, or neither, that means we need to find the slope of each line and compare them. So for example 1, if I look at the first one, I can clearly see the slope because it's in slope-intercept form. I would like a rectangle, please. There we go. So M here, I'm just going to put M1, since this is the first line, is 4. However, the second equation is not in slope-intercept form, so I need to rearrange it before I can ID the slope. So I'm going to subtract x from both sides. And then we're going to divide by 4 or multiply by 1/4, whichever you prefer. So y is going to be negative. Remember that 4 belongs to both the negative x and the 4. So -1/4 x plus 4 over 4 is 1. So for our second one here, this is our M2, and it is -1 over 4. So then parallel, perpendicular, or neither, we're just comparing the slope. So if I look at them, clearly they are not the same number. So the lines are not parallel because their slopes are not the same. So for perpendicular, I'm looking at opposite reciprocals. So if I look at slope 1, it is positive. Slope 2 is negative. So they are opposite. Reciprocal means the number flipped over. So if I look at the number 4, technically it is 4 over 1. And if I go look here, 1 over 4 is 4 over 1 flipped over, so they are perpendicular. So the lines are perpendicular. If you want to use the symbol, you can. In the homework, you're going to have to probably do a drop down or a type. Are perpendicular. Upside down capital T is the symbol for perpendicular. Because the slopes are opposite reciprocals. Or you could say the slope's product is -1. So again, opposite reciprocals or the product is -1. Either one is fine. Just depends on which one you have a choice of. Let me move that where you don't see it right on that line. Maybe. No. There we go. Just that. There we go. All right. 4B. Still doing the same thing, determining parallel, perpendicular, or neither. So first one, we can see our slope because it's in the correct format. Slope is -2. It's just not rectangle mode today. Third try always works. There we go. So M, I'm going to call it 1, is -2. Second line is not in the right format, so let me go get it there. So we're going to move the 8x. So 4y is -8x minus 6. We're going to divide by 4. So on the last one, I just used one division bar with the 4. If you prefer, because you're worried you're going to mess it up, you can divide both of them by 4 individually. So we get y equals -8 divided by 4 is -2x. -6 divided by 4 does not divide evenly, but it does reduce to -3/2. So we can see our slope number 2. All right, and then we compare. So if I look at them, they are the exact same. Therefore, our lines are parallel. So the lines are parallel. Symbol for parallel is 2 little parallel lines, or you can just write the word parallel. Because slopes are the same. All right. Next, here's some review of some formulas. Your slope formula, point slope formula, and then slope-intercept form in function notation. All right, example 5, find the equation of the line that passes through the point 3, 2 that is perpendicular to the line 2x plus 3y equals, so the 4 is on the next line. We'll get it brought down. Write your answer in slope-intercept form. So I'm going to copy the equation down since it's on separate lines. 2x plus 3y equals 4. All right, so here we don't have 2 points where we can find the slope, but we do know it's got to be parallel to this line. So the first thing we need to do is to find M, and I like the symbol for parallel. I need to find that parallel slope, M with 2 little parallel lines next to it. If you just want to write the word parallel, you can. So to do that, I need to get this equation written into slope-intercept form. So I'm going to move the 2x. I'm going to divide by 3. So we get y equals negative 2/3 times x plus 4/3. So the slope of this line is negative 2/3. We want, come on, pencil. There we go. For this is the slope we were given. We need the parallel slope, and remember, parallel slopes are the exact same. So we're going to copy that exact same slope here. So that's step 1. We need the parallel slope. We found it. Step 2, now that we have our parallel slope, we're going to take the slope we need, which is that parallel slope. We're going to take the point we were given, 3, 2, and plug it into point slope. We're going to plug in our parallel slope, M parallel, and the point that we're given, which is that point up there, 3, 2, to point slope form. All right, so point slope form, y minus y1 equals m times the quantity in parentheses, x minus x1. So our point is, 3, 2. So 3 is x1, 2 is y1. So we've got y minus 2 equals m, which is the slope we just found, negative 2/3. X minus our x1, which was 3. So we've got it plugged into point slope form. I'm going to rewrite it since we don't need those parentheses since there's no double negatives. I'll rewrite it here for point slope. That looks a little bit prettier. So then, once we have it into point slope, then you rewrite it in the form you're asked to give it. So it says write your answer in slope-intercept form. So now we're just going to rearrange to slope-intercept form, which is your y equals mx plus b from your formula chart. So we're going to go a little copy paste so I can get that below here. All right, so to solve for y, first thing I need to do is clear those parentheses. So negative 2/3 times x. Negative times negative is going to be a positive. Negative 2/3 times 3 is going to be 2. And then we're going to add 2. So we get y equals negative 2/3 x plus 4. So if we go double check, we found our equation. It is in slope-intercept form. This is our answer. All right, example 6, find the equation of the line that passes through the point 4, 5 and is parallel to the line 3x minus, oh, look at that. Oh, I just did parallel. So there's your little bonus. So I'm going to put a little note here. Parallel. See, words are important. I did parallel. Okay, so perpendicular. Let's come over here on this side. That's oops on my part, but I'm just going to keep it in the video because it won't hurt to do both. All right, so perpendicular. We'll scooch you over here. This is the way it's supposed to go for the example. So sorry about that, but again, it won't hurt you to see both. So we're just going to pick it up down here, or we're pulling our slope over here. So negative 2/3 is the slope we are given. To find M perpendicular, opposite reciprocal. So the slope we were given was negative 2/3. Opposite, make it positive 2/3. Flip it 3/2. So there's your perpendicular slope. So then we're going to pick it up at the same point. So I'm going to copy because I'm lazy. So we're going to pick it up at, actually we'll just go step 2 because it's the same directions. So we're going to do y minus 2 equals our slope 3/2 x minus 3. We have it in point slope form. Then we're going to go to step 3, which is to rearrange it to slope intercept form. So we're going to distribute our 3/2 minus 3/2 times negative 3 is negative 9/2. And then we're going to add 2. So we get y equals 3/2 x, and then negative 9/2 plus 2 is going to be negative 5/2. So there's the way the problem was supposed to go. So this is what your answer should actually be. So now you've got it both ways on the same problem to compare. So steps 2 and 3 are the same using either the parallel slope on the left or the perpendicular slope like it actually asked you to do over here on the right. Now we'll go to example 6 and we'll try to do this one correctly. All right, find the equation of the line that passes through the point 4, 5 and is parallel to the line 3x minus 6y equals 7. So parallel this time. I'm even going to underline it and write same slope. So maybe I don't mess this one up. All right, our equation is 3x minus 6y equals 7. So I'm going to bring that over here. 3x minus 6y equals, I think it was 7. Let me make sure. Yeah, 3x, good. All right, so step 1, we need to find the parallel slope this time. All right, so slope-intercept form. We'll just do this. All right, subtract your 3x. So we have negative 6y equals negative 3x plus 7. Divide off or multiply by the reciprocal of negative 6. Remember, it goes to both of these. So y equals, double negative makes a positive, fraction reduces to 1/2, and then minus the other fraction does not reduce. So slope of the line we were given, let me go make sure it actually says parallel, so I'm going to do this one wrong too. Parallel, yes, parallel. So M parallel is going to be the same, 1/2. All right, step 2, plug into point slope form. so plugging into point slope form, we've got our form y minus y1 equals m times the quantity x minus x1. All right, so our slope is 1/2. Our point is 4, 5, so the x value is 4. The y value is 5. I'm going to rewrite it without the extra parentheses since there's no double negatives to worry about. And then go check what you're asked. It says write your answer in slope-intercept form. So we're going to rearrange to that form. All you got to do is at this point just rearrange it to whatever form it's asked for or you're asked for. All right, so we're going to take that. I'm going to copy it down here. Whoa. I'm going to copy this down below. All right, we're going to distribute our 1/2. That is going to be 1/2 x minus 1/2 times -4 is going to be negative. That is 2. And then we're going to add 5. So we get y equals 1/2 x. -2 plus 5 is 3. There is the equation of our line in slope-intercept form. So, got a little bonus example on the last one. I'm just going to leave it there, so that way you've got both. All right, the rest are you try it. So if you want to try those with the blank notes and then check them with the completed notes, you can.